Alright, ladies and gentlemen, Mr. Elton here, trying to help you out with some of these linear inequality problems. And I want to talk a little bit about shading. Um, Specifically, when I graph this, I'm pretty confident that all of you, being my students, can graph a line in slope-intercept form like this line, y equals 2x plus 2, and then turn it into an inequality by deciding whether to shade it, or excuse me, dash it or not. In this case, it is dashed because it's not equal to, right? It doesn't have that equal to. It's just less than. And so instead I draw it like this. And I want to caution you, don't try to memorize some kind of rule. Just because y is less than x, don't think that we should be beneath this line. I would avoid trying to memorize anything like that. Instead, I want to revisit how we graphed really basic inequalities. Inequalities in one dimension. You know how to graph this. This is an open circle at 5 on the number line. And you know, similarly to why we dash this line rather than make it solid, it's because x cannot be equal to 5 at this point. If 5 is x, then I have a statement of equality. 5 is equal to 5, but this doesn't say equal to, it says 5 is greater than 5. This is not true. 5 is not greater than itself. So I leave this point open just to show that at that point 5, this inequality is not true. However, it might be close for points really close to 5. Anyways, you know from here how to figure out how to draw your arrow, and that's to plug in a number. For example, if I pick 2, 2 is over here, right? If you think about it, 2 greater than 5, that is not true. And what that tells me, since that's not true, is to draw my arrow the other direction. Similarly, if I'd picked a number over here, like, I don't know, 7, plug it in for x, I know that 7, is indeed greater than x. 7 is greater than x. So, I messed that up. 7 is greater than 5. And if 7 is greater than 5, oh yeah, I should draw this arrow in the direction of 7, because it's true. In fact, all these points are true, and that's why I have a line over here, because it's just the combination of all these points that are greater than 5 combined to make a solid line. Similarly over here, if I pick any number in the coordinate plane, like, I don't know, this point right here, if this point works, I should draw my arrow kind of in the direction of this point. But rather than an arrow this time, because in 2 dimensions, we represent space using a plane, and in 1 dimension we represent things in a line. So to show that there's space here, I need to actually fill in this entire plane if that point works. I recommend picking a single point like 0, 0 and see if that works. If you plug in 0, 0, 2 times 0 is 0. 0 plus 2 is 2. 2 is greater than 0. I think that is true. So 0, 0 works. It's safe to assume everything on this side of the line also works. And you can go ahead and shade your line. Now, I do want to point out that it is impossible for one thing on this side of the line to work, and then another thing, let's say 2, 1, not to work. That's not going to be the case, because this line right here is the dividing line. This line tells us when these two things are exactly equal. So logic tells us that if they're equal on this line, then one side of the line will be not equal, and the other side is equal. Well, excuse me. One side is not greater than or not less than. The other side is greater than or is less than. And the middle will be when they're exactly equal. If that makes sense. So in 1 dimension, so kind of show that back again in 1 dimension. Not equal is this empty space over here. Not greater than. Greater than is this filled in space over here. And then again, in the middle, separating them is just a point. But in this case, we have a line. Okay. So hopefully that helps you a little bit. My explanation wasn't super clear. feel free to ask me in class and I'd be happy to give you another explanation. Thanks, guys.